Okay, the next topic I want to talk about is text file processing. And the main reason I want to talk about it is it's not terribly useful, but it does come in handy. And it's actually a pretty good technique to learn for all languages. And you did learn it in programming logic beginning. You might not remember. It was February, or intermediate, excuse me. It was in that February time frame where you learned how to read a text file. And the logic at the time was it's a great place to store because you can write to text files as well. It's a great place to store information, maybe high scores, maybe user information. Just throw it in a text file instead of some convoluted little mini database that most apps use. So I want to go over how to read a text file from here, but what we first have to do then is create a text file. And I discovered on the Mac there's no easy way to create text files, just I haven't found it yet. So what I did is I created it in here using Android Studio. So if you want to follow along, what I did was a file new, and I just did a file new file. What do you want to call it? Sample.txt. And then you can type whatever you want here. So I already have one, so I'm going to steal it. Just put my signature block in there. And then just hit save and it'll save it. And before the recording, I dug around and dug around and dug around, couldn't find it. It's really hiding in here. We just don't see it yet because this is already expanded. You collapse it and bring it back.
Right-click refresh.
Yeah, it'd be nice, but I don't think there is a refresh. I was looking for this the other day, couldn't find it. So I'm going to collapse the Java and expand it again and hope it's there. It's still not there. So where did I put it this time? Come on. Ugh. I did save it, didn't I? All right, we were looking around a little bit, trying to find it. And when I dug around, it was in my app folder, in my source folder, in my main folder, Java folder, com folder, example, Volker-Gall, debugging, and it's not there, so it didn't save it this time. Did yours save?
Mine's right underneath my main activity.
Yeah, that's where it should have gone. I thought I saved it. Let's try and do sample, see if it likes it.
Just close it and save.
Now it's there. All right. So hopefully you all have one as well. I just need some kind of a file to practice with, text file. And what I did at home using Windows, just opened up Notepad, typed whatever I wanted, saved it as a text file out here on the desktop. And that works. And now what we need to do, according to my notes, is put it into a raw folder. There's no raw folder. Why raw? For raw text.
Raw anything.
Raw anything. You can put video in there, you can put pictures in there. It's meant for media, but it'll handle text files. There is no folder. There are two ways we could do it. I right-clicked on Res. You can do a new, I think folder might work. I saw that down here someplace. But what I did is an Android resource, because we are in the resources directory. Directory is just a regular old folder. I think they both work, but I feel more comfortable with this one, putting it in my resources. Click. And I want to call it raw. And the resource type is raw. Click on OK. And now I have a raw folder. All that's in my notes. And now I want this text file to actually be in there. Now in the Eclipse version of Android, I used to be able to drag this. Let's see how it goes. Didn't like that.
Have a raw
No,
resource.
you have to create it under resource.
Resource type.
I wonder if I can
You
drop
already
it.
have a
I
raw
can't
folder?
drop it in resources,
So I have one raw folder.
but I can cut it
No, that's what I'm trying to create right now.
and paste it. Sure you know what you're doing? I think so. Now my sample text is in there. If you're using Windows and you use Notepad to create it, I could right click here, copy it, maybe. And again, right click on raw and paste. Now I have two. In my case, they should both be the same. You can have as many of these as you want. Every resource that I've seen says put your text files if you want to read them in a raw folder so that you can access them a little bit later. All right, got a bunch of junk going on here, not changing my context, don't need you. I'm going to go back to my on create and just put another method in here that says read text. Tuck it right underneath here, again for testing purposes. And here I absolutely positively need my notes. I almost thought about not even showing you this because you could read these as well as me. They pretty much follow my code. So I need an input stream. So in here, I'm going to define an input stream. And as most of the text do, I'm just going to call that IS for input stream. That is a pointer to an input stream. An input stream is basically a file. We're going to make this point to a file of some kind. A stream is a stream of characters that are coming at you one at a time, or bytes probably, one at a time. We need something to read that, so I need an input stream reader, ISR. That will feed me one character at a time. So this is a pointer to a file. This is a reader that keeps track of where am I in that file, basically. Then I'm going to create a, this is what I forget, a buffered reader. Yeah. A buffered reader, according to my notes, allows you to read an entire line at a time instead of one character at a time. That's convenient because typically I don't want to read things one character at a time and then I have to write logic that says when you hit the character turn, stop. Because the line's done. Buffered reader does that for me automatically. And then finally I'm going to create a string buffer that some of you have already discovered. And I'll call this one my text to break the rules here. A string buffer is like a string, except it's more powerful, it's a lot faster. So if you're creating a string that's very large, and my text file could be very large, right? Could be an entire HTML file. You could use Android to develop an HTML editor. Sounds like fun. Not really. Okay. If you have a very, very long string, string buffers handle them better. Concatenation in the string world is very inefficient. It takes one string, concatenates, no it doesn't. Makes a copy of this one, concatenates this one, makes a new string, and then makes this point to it. It's very inefficient. If you're doing itty bitty strings like we've been doing, okay, not so bad. But if you're doing larger stuff, you're better off with a string buffer. It's more efficient processing wise for larger strings. So there's the declaration. Input stream returns bytes. The input stream reader returns characters, and a buffered reader returns lines of characters. Couldn't I just get one of those? Nope, doesn't work that way. As you'll see, these are all linked together. And then finally, there's the string buffer that's a little more efficient. I think in C# it's a string builder, but it exists in all the languages because string processing with straight concatenation is a little inefficient. Okay, then we got some more commands here that actually tie them together. First of all, I'm going to take my source, my input source, my input stream, and link it to my text file. And that's pretty convoluted. Get the resources, open a raw resource, and then we use the raw resource ID. Okay, so underneath here, I'm not going to tie all these things together. I'm going to say that IS is equal to, what was it? Forgot already. Get resources. Dot get or open a raw resource. Which one? R.raw this time, not ID, because we put it in the raw folder. Could we have put it in one of those other folders? Yes, you can put it anywhere you want. Could I have left it where it was? I'm not sure how I would have accessed it. But I recommend creating this raw folder or a text folder or whatever you want to call it. Seems to make a difference. I need a raw dot, and there's my 2 sample signature blocks. You should see one. Notice the .text extension is not included. Remember when we were working with images, the .jpeg, the .png was not included on the file names in the resource name. The file name is still sample.txt, but its ID is simply the name. Without the extension. You put the extension in there, it will not find it. So now this says, point to that file over there. It's in my resources. Okay. Now we link the reader is equal to a new input stream reader. Did I do that right? Get resources. Yeah, okay. This one is a new input stream reader. Capitalize it right. Linked to that file. Yep. And now I need a new buffer that's linked to the reader. So this guy is ready to read characters, but I don't want characters, I want lines. So my BR is going to be a new buffered reader that's linked to the ISR that's going to feed it characters. You don't like that? Create your own class. Make all this happen behind the scenes. You could create your complete buffered reader class but then you'd have to feed it pieces of information. Where's the resource we want? And then inside it could create all these things, and you could do that. I'm sure somebody already has, and I haven't read about it. And now we're ready to read. Another thing we still need to do is initialize our string buffer. And did I do that in a separate one? Yes, I did, but I could have just done it up here. I don't think I need to link that to anything. No. So I could combine it like this. I was just doing all three because it was 1, 2, 3, 4, and then 1, 2, 3, 4. But this would just be down there. So now we're ready to read. We are going to read using the buffer, one line at a time. We're going to take that line from the buffer and we're going to stuff it into this string buffer and just keep concatenating it. So you're going to read one line at a time, put it in the string buffer, read another line, put it in the string buffer until we hit the end of the line, the end of the file. Remember in C#, did the same kind of thing. Kept reading until we hit the end of file, and many languages have an end of file type special symbol. In Android, there's no such thing. So again, looking at my notes, I'm going to declare a variable, string s. Every time I read something from that buffer, I'm going to put it in this variable. It'll simplify things a little bit. And now things get a little convoluted. I'm I'm going to keep reading until I hit the end of file. But how do I read from a buffer? We do a BR read line. Now even that ought to sound familiar. Now here's where things are a little weird. Let me retype it and hopefully it'll clarify it. But what I'm really doing is reading a line and immediately stuffing it into S. Interesting. S equals br.readline. So this reads it, puts it into an S as part of the condition of the while statement, and then we can check to see as long as that's not equal to no.
You get an extra set of brackets.
No, I don't. There's a different problem.
Oh.
What's your problem? Unhandled exception. Uh-oh. And this is new. But at least since the last time I taught it, readline throws exceptions, and I'm not catching them. You remember from our discussion on exception handling, if your business class, your problem domain, throws an exception, then the main program has to catch it. Same problem here. So this is new. So it's not here before. So what I'm going to do is just throw a try catch block around this thing. Make it shut up. So here's my end while. I better put my curly bracket on here. And then an end while. And I better indent these things. And here's my catch. And now this is happy. How come we didn't update your notes? Ran out of time. You copy my notes and you get errors, find out what's wrong. In this case, it was an unhandled exception. When you get that, that's Android telling you, Java telling you that this method, readline, is going to throw an exception potentially. Why would it throw an exception? If one of these was bad or never set or something happens with the file, it used to be there, now it's gone, I don't know. I could definitely see it throwing an exception if the file that I said I wanted to grab isn't there anymore. But then why wouldn't this give me an error? Don't know. Maybe there's a flaw in the file. I don't expect to hit this. So I'm going to put in here's a great place for a toast. Show it here. Here's my message. Problem reading the file. And toast. Oh. Toast. Capital T. Oh, there it is. Oops. Don't type the O. There it is. Like long. Don't forget to show. But don't expect to see that. I really don't even know how to test it because I don't know how I can break this process, honestly. Unless my program's running and then I go delete the resource, then maybe. But not worth it, but I got to put something in there, so that's a good place for toast. So let's analyze this a little bit. This says read a line from the buffer and immediately store it in this variable called S. And then immediately compare that to null, because this has got parentheses around it. It's a little weird to me. I don't particularly like it, but in a way I do. And I found this on the web, and it was, oh, cool. My version of this is a couple lines longer. And so this was pretty good. Seems to be pretty common, but recognize what it's doing is two things at once. It's reading, stuffing whatever it reads into S, unless it's null, unless it fails, it hits the end of file. Then it puts null in here. We compare it to null. As long as S is not null, we keep reading. So this is keep going until you hit the end of file. But if it's successful, S will have something in it which is not null, and the loop will continue. So all we really want to do here is add S to my string buffer. So my text dot append. And notice the append, when we looked at it, could have all different kinds of data. So you can append anything. Numbers, doubles, strings, booleans, you name it. You can append anything to this string buffer. It'll convert it to a string and go from there. What do I want to append? S. That's my variable. However, what I discovered with a little bit of playing around is this buffered reader reads and reads and reads characters until it hits the end of line marker, the \n, or however you want to picture it, the carriage return, it stops. The buffered reader does not, it absorbs that carriage return. It does not include it as part of the string. It just, that's its end marker, so it stops. And this S variable does not have a carriage return in it. So if I want my text view to display everything in the same way it was on the file, I have to concatenate a \n.
So if it's a blank line, which is, it won't be null, it'll just be.
It'll be a blank line, it'll be an empty string, which is different than null. The EOF would return null. When the read line command hits EOF, it returns null. If it finds a blank line in the middle of there, we could probably test it. Which one am I reading? Sample. And open it back up again. And let's put a blank line here. Save. Okay. But what that'll do is it'll read that, find the end of line marker, absorb it, but the string is still empty. And I think this is all we need to do. Yes. Just for demonstration purposes, let me show you what mine would have looked like. And you don't have to type this, I don't even recommend it. I'm going to use X just so I don't get errors. I would do this, X equals BR dot readline. While X is not equal to null, you see the similarities at this point. If it's not null, then append it. But somebody's got to get the next one. So I repeat this line. That's my version. That's the one that I learned back in school many bazillion years ago when the languages didn't allow this. All right. But you do what I call a priming read. Just start it. Were you successful? Because it could have been the end of file right at the beginning. You can have a file that's got nothing in it. Were you successful? Yes. Then append it. Get the next one. Were you successful? Yes. Append it. Where you can just keep going in this loop. This is the way I learned to write it. This does basically the same thing. Try to read something as long as it's not null, append it, and then try again. Over and over and over again. So when I saw that, I went, oh, cool. Genius programmers out there. That's how you get to be genius programmers. You see what other people do. Go, oh, cool. As long as it's not too tricky. Okay. This with a little bit of study is okay. And it's probably out there so many times, so many different places that you get used to seeing it after a while. Are we done? Not quite. Remember from Programming Logic Intermediate, whenever you open a file, you should close it. And in this case, I have to close all three of my pieces parts. My buffered reader has to be closed, my string reader has to be closed, and my input stream has to be closed as well. When I tested this, I thought, well, I'll put those outside of my catch. Nope. The close could fail. It has to be inside of a try-catch, so I decided to stick it in here. br.close. Now these, notice I'm closing them in the reverse order that I opened them. Is that important? Probably, considering these things are chained together, and I don't want to find out. And then finally, I also want to display my results in my text view so that I can see it actually worked. So let's see, do I still have my TV here? Nope, I'm going to have to recreate my text view.
Text view. Oh, never mind.
Now wait a minute. I want to display what's in my string buffer, my text. But my text is not a string. It's a string buffer. Good news is, it's simple. Turn it into a string. So it takes this convoluted string that really isn't a convoluted string. It's just processed a whole lot faster and turns it into a regular old string so that we can play with it once we're done playing. If you're playing with large strings, use a string buffer or a string builder. Once you're done, then you can convert it to a string and use it like any old string. And so again, this was called, this is a lot of text or a lot of code here. This was called in onCreate. So what I expect is that my signature block is going to show up on the screen right away. Because I called in an onCreate. We define all these pointers, link them together, and then start reading. Everything we read, S, one line at a time, append it to the string buffer. When we're done, shut everything down and display the string buffer in my text view. Makes perfect sense. Reen is nodding, doesn't mean it's going to work. So I expect this to display my address right away.
Ooh. Did you press me? Does it change the modulus?
This press me do, wipes out whatever's in here and puts the modulus there. Should.
But
What did I do?
oh, there you go. There you go.
Why did that take so long? It's going to happen 5 or 6 times. Why did that take so long? Oh,
Blame me.
I clicked it twice. And also notice, as long as Visual or Android Studio is still running, this debug filter sticks. Now, it's probably not going to be there when I shut this down and come back, but all you have to do is type it in once. And if you use the same tag, like Volker tag, over and over and over again in all your programs, you don't have to worry about it. You just put the same thing in there all the time. I think this is going to be a place to stop, primarily because the next thing I wanted to show you is how to create a menu. But in order to do the menu, I have to have the little menu button up here. And in this newfangled version of my Visual Studio here, it's not there. Remember what I discovered the other day, or last week, is I don't know if there's something wrong with the emulator, but when I go into the layout, it shows me something different. It shows me a gray screen. And it shows me my name and icon over here. Remember we had this trouble last week when we were doing icons. And this is where your menu would normally show up, but I don't see the menu here. Even though I have the same code here, this, when you build menus, we don't even change it. This we change to find out which button did they pick, and my notes explain it. So if you want kind of a head start on part 2 of the Unit 5 assignment, you can do that by reading my notes. I don't think it's hard. But there's something goofy here. I got to figure out how to do it in the new version of Android Studio. It's not as simple as simply changing my theme, because it still left a bunch of junk in there. And notice the stuff I took out. It's got some interesting names, like a floating action bar. Ugh. Okay, it's floating, so how do I bring it up? I have to play with that a little bit. Yes, sir.
You might want to mention text files have to be lowercase.
Everything that's over here has to be lowercase.
Yep.
Anything that's in here, notice, except for some of this stuff here, but any files that you put in here, we talked about it when we were talking about images. We brought our own images in, they're all lowercase. If you make them uppercase, it'll let you copy them in there, but when you run them, your program will crash at runtime, and you'll have to find your way through the logcat to figure out what was wrong.
Lowercase and no spaces.
No spaces, correct.
Does your emulator have a menu button on it?
Here?
Yeah.
Nope. So I don't think this is, I think this is just apps. Yep. And this is take me back to the home screen, and this is back one button. Oh. It's annoying. Debugging. Now, why didn't it start over again?
Is it still in memory?
And never ended it. Still in memory. So when I found it, I said, bring it back. I'm not done with it yet. If you want to end it, that's where this guy comes in. And I also discovered on mine, I got a warning on mine at home
Yeah.
on the emulator saying you're running out of memory. What? Every time I grade one of yours, it senses it as a different project, and I run it in the emulator to see if it works, obviously. So I had all of these loan calculators, like 17 loan calculators. They all call loan calculator, but they're different apps. It sensed the difference, even though they have the same name. So I just had to go through, and there's no easy way to delete a bunch of apps at once. You could kill the emulator and rebuild it, but it just wiped them out. So I'm going to do a little work, maybe if you guys, either today or before next week. I'll show you how to do menus next week. If you want to get to it and you're using the older version of Android Studio, and let's again check to see which version I'm on here. Ah! Is that under help? Search, help, tip, pro tip. Where do I find the version? Check about. There we go. So this is 1.4. If you're using 1.3.2, which is the one before this one, my notes are current because that's what I was using in my office. That's what I got on here. Right now, this is the only 1.4 I got. Fortunately, it's the one I have to use to do lectures on. So I will figure that out somewhere along the way here so I can get this to work, either by bringing it back to show me an app like it did before, or figuring out how these floating action bars work. But if you're getting bored, and I know that some of you have turned in Lab 5 Part 1, I won't tell you who, because everybody else come beat you up out in the hall.
All right.
You don't know who, trust me. You think you know who. I have cleaned up my website a little bit so that 3 and all these are all kind of in the right numbering. I combined these two. But Lab 5 has been modified. I still want you to turn in Lab 5 Part 1. It's worth 10 points. And Part 2, probably going to be worth its own 10 points. I'd think about that a minute. Yeah, probably its own 10 points. If it tends to get complicated, maybe I'll bump it up and make it 20. We'll see. But for Part 2, remember in Part 1, for those of you who haven't even started yet, you brought in 3 to 6 pictures of something that's related. I brought in 3 different minions from whatever, what's the name of the movie? Where do the little yellow minion guys come from? It's a quiz.
Despicable Me.
Despicable Me. I brought in 3 pictures of minions. They're all related, and I brought them in. Fine. That's all you got to do. Find 3 related things. Create their app. Make the images. Modify the images so they fit well in an Android environment. Add them to your project. And then display them on the screen. Now, the curveball I threw you, because we never showed you how, but you should be able to figure it out, is when I tap on the minion, go to the next one. Go to the next one. Go to the next one until you get to the last one, then cycle back around to the first one. That's what this lab is going to do. In Part 2, I want you to create corresponding text files. So what I'm going to be doing when I write my key is creating a biography of minion number 0 and saving that into a text file. And a biography for minion number 1. And don't steal my minions. Anybody turns in minion projects gets a -5 for unoriginality. If you really love minions, you better bribe me. But a text file for each one of your pictures that describes it. In the past, people have done presidents, and they say he was the 16th president, and his name was Abraham Lincoln, and he was born here, died here, all that kind of stuff. 2 or 3 sentences. I don't need a big, huge biography for every president. Of course, if you go into Wikipedia, you could steal it, right? And so you had to type it all. And then every time I touch a picture, change not only the picture, but the text that goes with it, and cycle all the way back around again. A little later here, you know how to do this already. It says somewhere put in a logcat message. Somewhere put in a toast message, which shouldn't be hard because I showed you where to put a good one today when you're reading from the files. You need to have a catch. You might as well throw toast in there. That's good enough for me. And then what you haven't done yet is create icons for action bars. My notes will tell you how big they should be. Do not use the same pictures you used for the big picture. Don't use those. It'll work. Don't do that. It's the wrong size. Either shrink them down, crop them, do something, and make icons for the action bars that relate to each one of your pictures. Add them to the action bar, which is basically the menu. And now when I click on picture number 5, you take me immediately to picture number 5 instead of making me go through the cycle. And then you'll have a nice app for your granddaughters, daughters, whatever, to flashcards, basically, right? In the future, I think what we did in the past, what we did in the future is actually swapped it so that the picture sits on top of the text file. And if you long press it, it flips them. So now you really can do flashcards because the picture and the text are flipping and they cover each other up. Or you shrink the picture and show the text and then make it full screen. All kinds of cool things you can do, little flashcard programs here. This is a starter for it. Part 2 is probably not due until a week from Friday. Part 1 is due Friday. That people who did, trust me, it's not hard. I did give you the hint here. I mentioned it in the recording last week. If you use array lists, really simplifies the logic of this. Of course, you got to get your head around the array list. But if you can find a way to use an array list and create an array of pictures, really simplifies the logic. Otherwise, you're going to switch statement yourself to death. That's appropriate. It's just hard. So this one's probably due a week from this Friday. That should be okay. And next Monday, I will give you this if I have to plug in my laptop. I probably could do that today, but you've had enough. If I have to, I'll plug in my laptop, show you how to do it. And if anybody's upgraded to 1.4, hopefully we can get it figured out by then.